Hi, everybody. I'm Bob Bowman, Editor-in-Chief of Supply Chain Brain, and I welcome you to this presentation on cross-industry advancements in mobile robots, the second episode in Deloitte and Supply Chain Brain's webinar series from 2023-2024. One quick note, there will be an audience question and answer session at the end of this presentation. Audience members are encouraged to submit their questions at any time during the presentation by clicking on that Q&A button at the bottom of your screen, and we'll get to as many of your questions as we can, time permitting. Now, robotic hardware and software applications are hardly novel these days, yet organizations continue to face challenges in selecting, integrating, and sustaining the right robotic solution. These hurdles can be tied to numerous factors, including the rapid pace of technological improvements and the shadow cost of change management efforts. So today, we're going to examine where robots fit within an organization's enterprise architecture and highlight opportunities to take advantage of trends in the robotics industry. We'll also look at the issue of human capital and learn why a human-centered approach rooted in trust is a crucial ingredient in successful implementations. With that, I want to introduce our speaker for today. Kathleen Felter is Manager of Supply Chain and Network Operations with Deloitte Consulting LLP. Kathleen has also held roles within the Office of the Chief Technology Officer and Deloitte's Emerging Technology Incubation Group. Her focus in recent years has been on the study of robotic applications in flexible conveyance and material inspection. With that, I want to turn it over to Kathleen Felter. Kathleen, take it away.
Bob, thank you so much. Good afternoon, morning, evening. Kathleen Felter, as Bob mentioned, and I'm going to get right into the agenda and kind of double click into what Bob has referenced we'll be talking about today. So we're going to be looking at the market, how that pertains to one's organization, and I know we'll have some question and answer time here at the end. So in terms of the market, when we're talking mobile robots, what is the state of the market, and really what do we mean by a mobile robot? Then we'll also take a look at trends surrounding the technology as well as the vendor landscape. And then for one's organization in particular, how do physical robots demonstrate value, and what are the complexities that come along with that type of implementation to one's organization? And then we'll get a bit more technical and talk through where robots fit within an enterprise architecture. So let's see here. So next slide. All right. For types of physical robots, there are, or as humans, I should say, we want to bucket and put the technology into categories or compartments to make sense of it all. This isn't an official categorization, nor am I claiming it's exhaustive, but this is how I, Kathleen Felter, have been able to make sense of this market. And so that is 5 different buckets. I'm going to start with humanoids. So those are built to really, in the title, look like humans and interact like humans do, with limbs as sensors and actuators. So many use cases here, not as much in, I'd say, supply chain and the warehousing and logistics arena, but a lot we're seeing that advancements within healthcare, hospital settings, and elderly assistance. Then we've got exoskeletons. So with exoskeletons, we're talking about wearable equipment that helps enhance the performance of the worker. So that's, think heavy lifting and think protection and safety as those major value drivers for exoskeletons. And then autonomous mobile robots. So AMRs for short, they come in many shapes and sizes, and I'll get into that more here in a little bit. Before I do, robotic arms, I'd say that is the most established technology as it relates to physical robotics on the market now. We see those well established in the automotive industry and with material handling, painting, welding tasks that fit into that category. And then hybrid can look like a combination of any of the technologies that I just mentioned. And so autonomous mobile robots. Oh, let me go back a slide here. So autonomous mobile robots. A ton of different applications. And before we get into those applications, they can look a lot of different ways too. And so you can have a legged AMR. And I think a classic example of that is the robot dogs that we see. If not in application, we see them certainly on different YouTube R&D site. So those versus wheeled. They also operate on different terrains. So that could be outside, between warehouse settings, between manufacturing plants on the same campus. That could be indoor, going from work cell to work cell. So you hear AGV and AMR used interchangeably. And I want to set the record straight here that they are not, in fact, the same. And so I think it's important to differentiate the two as we continue this conversation. So AGV stands for Automated Guided Vehicle. AMR is Autonomous Mobile Robot. So already within the name, we have automated versus autonomous. AGVs require a controlled environment, a fixed guided route, that usually necessitates some type of magnetic strip, tape, or wires to guide the technology. Whereas AMRs, they are able to maneuver autonomously throughout their environment without that fixed infrastructure. All right, well, what is an AMR made up of? So we've broken it down in this example into 4 different parts. The first one is, and I'm going to start at the bottom here, the base. So robot manufacturers offer a ton of different options here, and it really depends on the use case and application. So when we talk base, we're talking, again, wheels versus legs. The vision system that goes on top of or goes within the base to help or aid in the robot sensing and actuating. Then up a level is the topper. So I mean, there's a lot of different types. We've got totes, carts, pallets. You can order or create a custom topper if you so choose. Then the scanner. So that could look like an RFID or barcode scanner, which helps to facilitate the tracking of whether it's something on top of the AMR, so a part or an item, or to help facilitate the location of the robot in its environment. So coming in and out of different work cells would be an example there. And then lastly is the human-machine interface. Can look a few different ways and can come from the robot manufacturer, or can also be a payload or an add-on after the purchase. But it's essentially is a onboard tablet that provides system-directed instructions to the worker. So, and I'll talk a second too about design principles of the technology too. And it's really, again, I'll always come back to, it's going to depend on the use case, and we'll get into some of those in a bit. But those different applications are, improving adherence to a task queue, minimizing infrastructure requirements, minimizing disruption to existing operations, or simply to decrease walking or fetching for human workers. So the market. The market, it's a pretty staggering number here on the left-hand side, but between 2022 to 2032, so over the next 9 years, the warehousing and logistics market for AMRs is expected to grow $17 billion by 2032. We're seeing too that the market is very saturated, very fragmented, and 1,000+ companies worldwide that are manufacturing autonomous mobile robots. Just in recent years, like I'll pull a few examples on the slide here. So Fetch Robotics, that was acquired by Zebra in 2018, 2019. And the consolidation of the market is really going to continue, really for the foreseeable future. We're also seeing not just technology peripheral type companies acquiring these types of startup companies, but also mobile network companies, ERP, enterprise resource planning platforms are all acquiring a hardware component. And when we look at adopting, implementing, procuring this type of technology, we've seen a few different pricing models. I'm going to highlight 3 here now. Again, not exhaustive, but want to give everyone a flavor for how this type of technology is being marketed. The first one, and I'd say the original one, is really just direct buy from a vendor or a resale channel. So with direct buy, that is the ROI can be expected in a shorter time as compared to other models. And then maintenance and service costs must be added as part of an operational expense. And then lastly, employees really need to be trained to function and monitor. So that's not provided if you're buying it outright, unless you're buying a service contract, and that'll get into number 2 here. It's really the responsibility is on the organization to service, to monitor, to collect data, do the day-to-day for the hardware. So for the second one, robots as a service, or RaaS, as some call it, there's no capital expense required. It is all taken care of as part of an operational expense. So ROI might be achieved in a longer time frame. And then in addition, I apologize, employees are given training and provided services on some cadence, usually a monthly basis. So let's say, I think on average right now, an autonomous mobile robot is going for 30 grand in the market. Well, that cost is broken up over time. And on top of that, a service agreement is signed between the vendor and the organization. And so really the organization has system integrators that are part of the vendor organization that can come on site to maintain, to troubleshoot, are available to take a look at integrations if data that the robot is collecting is not flowing to, whether it be the warehouse management system, the ERP system, And that is a big trend that we are seeing in the market currently. It also, I mean, a big benefit of this is it allows the customer just a lower barrier to entry. And then lastly, this one not as common, is pay per pick. So the customer is charged based on the number of items, parts, whatever it is that are picked in any given day. So it's linked more to the performance rather than the outright sale of the technology. All right, I'm mentioning a lot about use cases, and there's 4 here that I wanted to double click on. The first one being order fulfillment. Order fulfillment seems pretty straightforward, and actually all of these use cases they're all anchored in material movement, material flowing from one part of an organization, one part of a factory floor to the next. So for order fulfillment, workers will cover zones in a warehouse and load that autonomous mobile robot with items from whether it's a shelf, a worker queue, a cell, whatever it is. And then that AMR is going to take that material, that part, that component, and deliver it to the point of use. Replenishment. We see that, I'm talking a lot about factories, I'm talking a lot about warehouses. There's also I'd say a hospital setting is really good for this use case too. So think about a AMR going and restocking hospital rooms, whether it's bed sheets, whether it's prescriptions. Replenishing stock is a huge use case, and I'd say pretty mainstream one we're seeing with autonomous mobile robots. Material handling, and I'll use a hybrid example for that. So the robots where we have an AMR and mounted on top of that is an articulated robot, or a robotic arm as it's also known. And that robot is able to handle material that might be dangerous and transport it to be discarded responsibly. And so worker safety really is that value driver in that type of use case. And then lastly, what we're calling flexible factory. But instead of using any fixed type of belt or conveyor, we're using an AMR to move products from one cell to the next. I'm going to talk a little bit now, talked a little bit about the market, moved into use cases for organizations, and now I want to talk a bit about value and complexity considerations. So let's start with value drivers. This list, not exhaustive, but want to give folks an idea of here are the different ways value can be realized by adopting this type of technology. And that really depends on an organization's mission at the end of the day. So let's start with safety. Decreasing exposure to workplace risks or hazards, handling hazardous material. Those are just a few examples. And then impact on throughput. So increasing the rate of production output within a certain period of time. Huge value driver. Then let's move to strategic alignment. So alignment to improving strategic priorities for the organization. And again, those could be safety, those could be impact on throughput. but making sure that whatever the value that you are realizing or you think you're realizing through this type of adoption of automation is really in line with your organization's strategic priorities. Then workforce efficiency. So enabling workforce to allocate time to more value-added tasks rather than what I'd referenced as fetching or moving items, and being able to focus on if we're in a production or a repair environment. The machining required, whether it be welding, painting required, that is adding value to the part or component rather than moving it along to its next station. Maybe that's cleaning or non-destructive testing. Floor space savings. So improves or increases free space on a production floor and opens it for perhaps adding additional work cells instead of having that space being taken up by a conveyor. Flexibility. So that enables faster and easier transport of goods. And it also, in addition to faster and easier, flexibility is timing, where we can look at flexibility from a workforce efficiency lens as well. So enabling workforce to allocate time to more value-added activities, like we mentioned, and then also changeovers to support different products and processes. So the robot itself, there are a ton of different applications, and so maybe it's working in one warehouse, or a fleet of robots are working in one warehouse one day, and they are moved to the next warehouse another day. We're thinking about multiple in one place. And we'd also mentioned too, moving between warehouse and warehouse. Then data capture. That facilitates improved visibility into key metrics like cycle time by automating that data capture through computer vision, through the sensors that are mounted onto the robot itself. Okay, so let's see. We're going to move to complexity considerations here next. So when we think about complexity, after going through those value drivers, and I've been talking about, adoption, the implementation of the AMR, regardless of the value that it adds, it must always be looked through two different lenses. So for complexity, and I'll just go through a few of these, and then I'll deep dive here on organizational readiness too. How difficult is the hardware in integrating it with technology that already exists on your factory floor or in the warehouse? That could be conveyors, elevators, doors. What are those other technologies, or what are those roadblocks that we need to make sure we are integrating? Then the systems too. So does the process rely on communication between multiple systems? So the warehouse management system, the MES system, the ERP system. How many APIs need to be built for that data to be transported from the AMR into the systems that the workers are using day in and day out? Then automation requires certain interfaces too. So the onboard HMI that I had referenced earlier. So ensuring that the existing information systems are able to integrate and interface with the HMI is going to be paramount. Then we have tolerances, number of business rules. So a good example of tolerances would be how far or are there any compliance requirements for an AMR getting within a certain distance of a work cell or within a certain proximity of a fellow worker. And so if foot traffic is really high in that setting, that's certainly something to take into consideration in making sure that the AMR is able to quickly adapt or stop if someone is walking in its path, between 5-10 feet, whatever that tolerance needs to be based on the setting. And then I'm going to skip down to organizational readiness here. And this really hits a point of company culture and figuring out how ready is one's organization to take on this type of really big change, frankly. What are the business outcomes your organization is looking to achieve with a blended workforce? And how we define blended workforce is simple. It's the mix of humans plus machines. What outcome is one trying to achieve of those value drivers that I had referenced? What will be the need for your people to drive towards these outcomes? And then also tracking and measuring the success of the blended workforce. Those are all questions that need to be answered before any type of pilot or really any type of proof of technology, making sure your business, your stakeholders are all on the same page, and then making sure we understand and the business understands the sentiment around what it means to bring this type of physical automation, and not talking, robotic process automation. Sure, there are a ton of human capital implications to the AI aspect of a robot, but starting with the physicality of it and having autonomous moving computers in one's environment, change management can be a huge shadow cost down the line if those questions aren't answered at the get-go. I'm going to get a bit more technical here in this next section. So robots in enterprise architecture, where do they fit into an organization's technology infrastructure? So for those familiar with the Purdue model, that's how I've set up the 3 layers. So process and control, operations, and enterprise. So the process and control layer. Bottom left, we're looking at robotic hardware. So this, when we're talking about the hardware at this layer, we're talking about, okay, say there is a direct buy transaction. The hardware is shipped to your warehouse. You open the box. This is what's included. This is the off-the-shelf, what the vendor is providing, the sensors, the computer, the actuators. Those are the 3 main components to robotic hardware. Now the software, that looks like a lot of different things. The operating system, the control system, the human-machine interface, any computer vision payloads that are part of or mounted onto the base itself, path planning, kinematics, collision avoidance, simulation, and then peripherals. So what already exists that the robot needs to be communicating with, conveyors, buttons, elevators, any type of infrastructure. Operations layer gets into the site and the fleet itself. So site planning, site management, and fleet management. If you've ordered more than one robot, you then, 2 robots equals a fleet, a small fleet at that, but a fleet of AMRs. And so making sure those are monitored and programmed to orchestrate with each other and collaborate with that blended workforce is going to be key. And having that situational awareness of mapping a site and then deconflicting any traffic. Then lastly, the enterprise layer. So ERP software, asset management, customer relationship management, a ton of different modules that go into an ERP, and that data is relayed down the chain to the robot itself and vice versa. Then enterprise applications, so an e-commerce storefront, PLM, centralized alerts, and then central data, so centralized storage, file servers, analytics, and visualization. I touched a little bit on fleet management. I want to go into the different types of I suppose what I would call considerations as well as capabilities of a fleet management platform. And a fleet management platform can come from the vendor. Where that gets tricky is when we're talking a multi-vendor fleet. And so it requires a lot of vendors their fleet management software is just pertaining to their vendor technology. So if we do have a multi-vendor fleet, interoperability is a big consideration. So coordination and control across a multi-vendor fleet of robots, utilizing a standardized abstraction layer, traffic deconfliction, specifying how a mobile robot should avoid both dynamic and static obstacles, task allocation, using data from high-level enterprise systems and low-level equipment, the analytics and monitoring piece, optimizing usage and efficiency, increasing that per robot return on investment, and then the analytics and reporting uptime. Then teleoperation, that would be remote control of the robots to resolve any issues and to continue to improve performance. And then lastly, simulation. So testing those operational strategies in some type of digital twin or model before deploying the robot itself is huge for testing the value you're expecting, whether that's throughput efficiency, whether that is flexibility. That can be done in a variety of different simulation tools, and a lot of fleet managers include that simulation functionality.
Fantastic. Thank you so much, Kathleen, for that really deep dive into this topic. That was extremely educational. I now get the opportunity to take us into the panel discussion portion of our discussion here and have the privilege of asking you a few questions before we bring the audience in, and they also have questions for you, so get ready. Right. You did cover the strategy and planning side very well, but I'm wondering what types of activities would we expect to see in an implementation and a sustainment of these systems?
Sure. So implementation, a lot of different great activities that go into that, right? So starting off with just a pilot and starting small and then scaling across operations is going to be really, really important. And that is certainly not unique to robotic implementation. So for implementations, the tasks that the robots are going to perform need to be configured. And so they're called activities or missions, tasks, whatever the robot has been procured to do needs to be configured in that fleet management platform. You also have, I had mentioned the systems integration. So developing that integration logic to allocate the right triggers from new and existing systems, testing those integrations. So designing and running task workflows to confirm that the robot is performing as expected. There's also the compliance testing too. Those would be a few, Bob, I would say. So the configuration to the testing, to the, there's certainly an organizational change management implementation piece to this as well.
I'm interested in the actual market activity related to AMRs or autonomous mobile robots. Can you talk about what trends you've observed in that way?
Absolutely. The market I'd mentioned earlier in my presentation is very fragmented. And so the number of vendors in past years that were just focused on one bucket or area of the technology. So whether that's the hardware, the software, the fleet manager, those three are in my mind how I view the market. The vendors were only focused in one of those areas. We're seeing now with that consolidation of the market, really a one-stop shop for this type of technology. So the vendor that is providing the hardware is also providing peripherals. They're providing add-ons. They're providing the computer vision, the cart, the tote, and then they're also providing, as I mentioned, the fleet management and simulation piece as well. So going from providing just one part of the solution to companies that now want to provide an out-of-the-box holistic solution is one of the bigger changes that we've seen in the market in the past few years.
Thanks. How are clients reacting to this technology? I mean, it all sounds very exciting and definitely a plus for facilities to adopt, but is there some, and I think there is, some general hesitation in the minds of people who think that, quote unquote, robots are coming for their jobs? How do you explain and assuage that fear?
Absolutely. That sentiment has been around, I would say, for a very long time now, and how organizations or whoever it is that is working with these employees on a day-to-day basis, they need to be brought in at the start of a decision or a strategy around a robotic implementation. So bringing those people along for the ride and having them realize the value, and specifically the value that pertains to their job, where, hey, you are now able to focus on your craft, which is maybe machining or welding, versus okay, you have to move these parts left in, to a different work cell. You have to complete compliance testing, those types of activities that are completely necessary, but perhaps not the part of the job that employees are most passionate about.
Yeah.
So by bringing them along for, again, the ride, and making sure that whatever the change management strategy an organization goes with starts from the top down, but you're bringing the people that are going to be working with the technology on a day-to-day basis through the decision process.
Kathleen, let's bring the audience in at this point, because we do have some very good audience questions out there, and I want to get to as many of them as we can, time permitting. This first question says, what type of peripherals on a warehouse or factory floor would an AMR interact with?
Sure. So let's start with 5G and mobile infrastructure. So autonomous mobile robots, they are able to use regular Wi-Fi or 5G connectivity to move around a warehouse. So making sure that the connectivity throughout a warehouse is consistent is going to be really important, because sure, AMRs are smart enough to, if they lose Wi-Fi connection, are able to, based off of a mapping that they did when they entered the facility to understand their whereabouts, get back to a place where they can find connectivity. But that's an important peripheral that an AMR needs to make sure that it's integrated with. Another thing would be, I mentioned the example of doors. So if a warehouse is sectioned off with doors, with fences, ensuring that the integration exists for when a robot moves toward a door and gets within a certain tolerance, the door will open and then close behind them too, which is, you know, something that a human worker doesn't think twice about, but that's a type of training that robots need to make sure that they are fitting in seamlessly with operations. So doors, fences, that the internal infrastructure to the building. I mentioned connectivity, and then peripherals on top of an autonomous mobile robot might be a camera where they're doing some type of inspection of goods, items, components, whatever it is. That's a peripheral that would go directly on top of the base of an AMR.
Several questioners would ask for you to drill down a little bit more into this idea of what the difference is between AMRs and AGVs, especially with regard to relative adoption, maturity of the technology, and whether, in fact, we might see the lines between them beginning to blur in some way. What do you think?
That's a really good question. AGVs that technology has been around a lot longer than AMRs. And so it's very established. It's an established market. And given its presence in that pretty high, because robots as a service is only really a recent trend we're seeing. So a lot of that AGV equipment that has been bought outright, and in order to realize a return on that investment, those AGVs sometimes need to be kept around for a lot longer of a lifespan than maybe they were intended for. Again, depends on the use case. AGVs we're seeing too, because in the robotics market, it's such a fast-paced market. The technology is always evolving. AGVs tend to become we're seeing a bit more obsolete. The flexibility too with requiring magnetic strips or wires, that certainly doesn't lend itself to a flexible factory or warehouse. And so autonomous mobile robots, they don't require any type of infrastructure on the ground, no guided path that they need to follow.
Mm-hmm. Okay. This questioner wants to know, what applications of hybrid robots do you see as relevant or becoming more mainstream?
Mm-hmm. A lot of what we're seeing with material movement is a worker putting a package on a autonomous cart, and that cart moving to the distribution part of the facility, and then that worker receiving it, picking up the package. One of the big trends with hybrids in that use case is when you put an articulated arm on top of a mobile robot, they're able to take over the picking and placing on the base of the AMR that is moving the material. So a big thing in the hybrid world is really the articulated component as a topper for an AMR base. And then the intelligent inspection piece to it too, putting cameras, high resolution cameras on top of AMRs so that they can inspect, in this case, packages.
Are fleet managers typically cloud-based or on-premises?
On-prem was the case, I'd say 5-10 years ago. Now, a lot of these fleet managers are moving to cloud-based. They want the fleet managers, the vendors, not only want to sell the hardware, they also want to play a part in the service of managing the fleet and the software for the customer. So both certainly exist, but you'll see vendors pushing you towards the cloud solution.
You talked already about pricing models. This question is a couple of questions regarding that. I'll ask them in order. First of all, how expensive are AMRs?
Classic consulting answer, it depends. They range. The price point really ranges. There are, on one end to the left, we see you can get like for 10, 15 grand, a pretty basic base for material movement. Where that price starts to increase is when you start dealing with more difficult terrains, when you start seeing custom toppers put on top of that base, when you start to see the hybrid, so the articulated machinery, the computers that go on top of the bases, that's when you see those really increase into that 30 grand price range.
And secondly, this questioner wants to know what a RAS, or Robot as a Service contract, looks like. And I guess maybe they're asking in terms of term of contract, maybe the ability to scale up or down within the parameters of the contract, just all that stuff.
Mm-hmm. What I have seen in the market is for a service contract, on average, those can certainly range over a long period of time, but on average, about 5 years. And as part of that, there is on-site support as well as remote support too. It also includes troubleshooting and maintenance of the hardware when there's issues with that component of it. And then also the software as well. And so we're seeing more and more system integrators getting into this space because the folks that are making the hardware aren't necessarily the ones to help out with the integrations with the platform for traffic deconfliction, monitoring. And so that, I would say, is certainly a trend that we're seeing. And the RAS model really does push down that barrier to entry for organizations that might be on the fence or don't have the upfront capital investment to make in buying the machine outright.
Okay, here's everybody's favorite topic these days. How has the emergence of generative artificial intelligence, or Gen AI, impacted the use case for supply chain?
So generative AI, I would say, is different, related and complementary, but different from the hardware. Generative AI can be used to help a robot in the hardware make a decision and provide it direction. I would say we're not seeing generative AI capabilities yet necessarily on mobile robots. Will we in the future? Very possible. But generative AI, I would say, is a bit different from the artificial intelligence that is on top of or part of the payload for an AMR.
Thank you. I have bad news. We're almost out of time. I've been enjoying this conversation so much, and there's so much to learn, but unfortunately we are up against the time stricture, and therefore we have time for just one final question, and I have the privilege of asking it to you, Kathleen. Let's say I'm a potential user of this great technology. I want to get started. How do I get started?
How and where to get started in a landscape that is very vast with options. It's always really, really key to start internally. What do we have now? And being sure that the application that we're looking to solve for is exactly that. We're leading with the application or the solution and not the technology. And really what I mean by that is, don't go into your situation and say, I need autonomous mobile robots. It's a solution forward attitude is going to be really important. And this is no different approach from any other technology suite, really. And human-centered approach, that I'm really going to hit home, because the future of work, as we're seeing coming out of the years of 2020 to 2022, work is shifting and how we do work every single day. And how I see it is three pieces to that work: work itself, workforce, and workplace. So when we're talking about work, what is the human experience we're looking to give our employees? And how is that evolving from the traditional employee experience or the traditional job within these types of warehousing, logistics, factory settings? Secondly is the workforce. Blended workforces already exist and will continue to exist to become more complex, more mainstream in this era. So what does that right human to machine mix look like for a corporation? It is really important to pinpoint before we even decide on what type of robotic technology we want to implement. And then workplace. So within that mix of humans and machines, creating a setting that promotes collaboration between the two, and putting aside the fear or hesitancy of employees and making sure that is part of the strategy prior to implementation, it is going to be also paramount. And then, of course, safety. So between understanding the solution that you need, the application, prior to going out and doing a vendor assessment, vendor selection, and then building that automation roadmap, what are the milestones? How long do I want this implementation to be, based off of throughput needed, disruption to operations, are all really important considerations. And then now is the time to start engaging with your employees and understanding the root cause of whatever the issue or challenge statement is on the factory floor, and letting the technology follow.
It always comes down to change management one way or another, doesn't it, Kathleen? Listen, thank you so much. It was a great final answer on where we can get started and where we're going in the whole world of AMRs, AGVs, mobile robots. Thank you so much, Kathleen Felder, for that. I want to call everyone's attention to an upcoming webinar, which relates exactly to what Kathleen has touched on today. It's called Building Trust in Supply Chains. That's presented and hosted by Deloitte and Supply Chain Brain, scheduled for December 7th at 11 a.m. Don't miss that one. There is a QR code for you to access more information about it. And if you don't catch that right now, that, of course, will be provided to all attendees of this webinar after the fact. Finally, stay tuned for episode 3 in the Deloitte Supply Chain Webinar Series 2023/24. The topic will be supply chain workforce management. Look for it in January of 2024. Once again, Kathleen Felter, thank you so much for a great presentation. Audience, thank you for your participation, your great questions. Everybody, have a great day.